If the first and third of three consecutive odd integers are added, the result is 51 less than 5 times the second integer. Find the third integer. All right, there's a lot going on here. And I think one of the, probably the most important thing to identify here is that we have multiple unknowns. We actually have 3 unknowns here. So it says the first and third of 3 consecutive odd integers. So an integer is any positive or negative whole number, or 0. So we have 3 of them. And so we don't know what any of those 3 numbers are, so we're going to have to give each one of them a symbol. And so let's just list our unknowns here. The first number, we don't know what that is. The second number, we don't know what that is. And the third number. All right, so let's just call the first one x. And we don't want to use different variables here. We don't want to say x, y, and z. So let's see if we could express all 3 of these unknowns using only one variable, only using the variable x. Well, let's think about odd integers. And consecutive means one after another. So like 3 consecutive odd integers would be something like 5, 7, 9, or 21, 23, 25. Basically pick any odd number and then the next odd number and the next odd number after that. And so how do we get from one odd number to the next? Well, 5 plus 2 is 7, 7 plus 2 is 9, or 21 plus 2 is 23. So every second number is an odd number. So if the first number, if the first number was 5, we would add 2 to get 7. If the first number was 21, we would add 2 to get 23. Well, now we're just saying the first number is x. Well, if x is an odd number, the next odd number would be 2 more than x. So we could say x plus 2 would be our symbolic representation of the second odd number, and then 2 more after that, so x plus 4. All right, let me get rid of this for now. Okay, so let's see if we could translate this into an equation. If the first and third of 3 consecutive odd integers are added. First and third are added. Well, we have the first right here. We're calling that x, the first. And the third number is x plus 4. If the first and the third are added, the result is, there's our equal sign, is 51 less than 5 times the second integer. Well, the second integer we have right here is, we're calling this x plus 2. So 51 less than that means we subtract 51 away from 5 times the second integer. So just the 5 times the second integer, that's 5 times, well, the second integer is right here, x plus 2. So here's 5 times the second integer. And we want to take 51 less than that. So we want to take away 51 or subtract 51. All right, so that looks like it works. If the first and third of 3 consecutive odd integers is added, the result is 51 less than 5 times the second integer. Okay, so we've translated this equation, we've translated this word problem into an equation. All right, let's see if we can get rid of some of this blue so we can start solving the equation. And like I've said in previous videos, this is normally the most challenging or the most difficult part of solving a word problem is the initial setup, taking the problem, which is given in English, and translating that to the language of mathematics. Okay, so let's see, we can combine these like terms, x plus x, and we can distribute this 5 times x and 5 times 2. So x plus x, that's 2x, and we still have this plus 4, equals 5 times x is 5x, 5 times 2 is a plus 10, and then there's this minus 51. All right, so we want to get all our x's to one side and all our numbers to the other. But before we do that, let's simplify. Simplify the left, simplify the right. Well, the left is as simple as it gets. We can't do any combining there, but on the right, we have the number 10 and the number negative 51. So these two numbers, those are like terms, we could combine them. So I have 2x plus 4 is equal to 5x, a positive 10 and a negative 51, or 10 minus 51 is a negative 41. All right, so now let's get all our, basically move terms around. We could basically move this 2x to the right and move this minus 41 to the left. Or you could think about it as eliminating the 2x on the left and eliminating the 41 on the right. So we can subtract 2x from both sides. That will cancel those 2x's on the left. So we're left with just a 4. And we have 5x minus 2x, so that's a 3x on the right. And we still have this minus 41. All right, so we've eliminated the x's on the left. All of our x's are on one side. So now let's get rid of that negative 41, or that minus 41. So we want to get x by itself. So let's add 41 to the right, which means we add 41 to the left. So that cancels off that minus 41. So we're getting closer and closer to x by itself. We're left with 3x on the right-hand side. And 4 plus 41 is a 45. And now we're one step away. We have 3 times x. We want to get rid of the times 3, so we will divide by 3. And whatever we do to one side, we do to the other. Those 3's cancel, the times 3 and the divide by 3, leaving us with x. And then on the left-hand side, we have 45 divided by 3, which is 15. All right, so we have x equals 15. Now we have to take this back to x is a temporary placeholder, remember? So if x is equal to 15, that means the first number, which is x, the first number is 15. The second number is 2 more than that, or the next odd number, which is 17. And the next number is 2 more than that, or the next odd number, which is 19. Since the problem is saying find the third integer, our final answer would be 19 is the third integer. All right, and that does it for number 1. I'm going to do one more problem in this video, and then the other 3 problems on the worksheet I'm going to save for a second video, so it's not too much in one sitting, in one video. All right, number 2, find the measure of each angle of the triangle. And they're labeled as n plus 11 degrees, 5n minus 19 degrees, and 5n plus 34 degrees. Now, what do we know about triangles? Well, the sum of the 3 angles, or if you take all 3 angles of any triangle and add them up, you get 180. The sum of the 3 angles is 180. Now you don't have to write this out, what I just wrote in blue. It's just, this is how, normally I wouldn't write that down if I'm just doing this on my own, but this is my thought process. I have a triangle, there's three angles, we're looking for angles. We know that the sum of the three angles is 180. Okay, there's an equal sign. We know sum means plus. So we're basically saying take the three angles and add them together, and the result should be 180. All right, so we have three angles. The first angle, one angle is labeled 5n plus 34 degrees. So the second angle, which is 5n minus 19, so we're going to add that second angle, 5n minus 19. And if you want, you could put parentheses around these angles. They're not necessary, but we can put them there. So one angle plus another angle plus the third angle, which is n plus 11 degrees, equals 180. So the sum of the three angles is 180. All right, so we have some like terms we could combine. We have a 5n, and a 1n. And we also have the number 34, the number negative 19, and the number positive 11. All right, so the three reds, that's a 5n plus 5n plus 1n, so that's a total of 11 n's. And we've got a 34 minus a 19 plus 11. So that will give us a total of 26, positive 26. All right, looks like we're 2 steps away. We have to isolate the n, so get rid of the 26 and get rid of the 11. So the opposite of a plus 26 is a minus 26. So we'll do that to both sides. So we're left with 11 times n on the left-hand side, and 180 minus 26, which is 154. Now finally, one step to go. We have 11 times n, so divide by 11 on the left, which means we divide by 11 on the right. The times 11, the divide by 11, they cancel, and we're left with n on the left. And 154 divided by 11 is 14. So don't make the mistake of solving for n and circling this and saying, okay, I'm done. The question is, find the measure of each angle. N equals 14. N is not an angle. So we have these three angles. So we could say 5 times n plus 34, 5 times n minus 19, and we have an n plus 11. Okay, so those are the three angles. And if we plug the 14 in for n in each one of these equations, or each one of these angles, well, 5n plus 34, well, now it means 5 times 14 plus 34. And if you want to verify this on a calculator, you can, but 5 times 14, 5 times 14 plus 34 is equal to, let's see if we could get a little bit more room here. 5 times 14 plus 34 is equal to 104 degrees. Then we got 5n minus 19, so that's 5 times n, which is 14, minus 19. So if we take 5 times 14 minus 19, we will get 51 degrees. And then finally, n plus 11, which is now 14 plus 11. We get 25 degrees. Okay, so that would be the answer. The three angles that we're looking for, and that answers the problem. All right, I hope this was helpful. I will do the other three solutions in my next video.